G'day guys, in today's video we're going to be showing you how to change the universal joints on the front and rear propeller shafts of this 80 Series Landcruiser. The video is going to apply to all 80 Series, so that's from 1990 to 1997, and we're going to be installing these high quality aftermarket Japanese universal joints that we've picked up from Terrain Tamer. The video is going to run you through how to diagnose a bad universal joint, as well as all the tools and parts and torque values you're going to need, and a few tips and tricks we've picked up along the way. So let's jump right in. We'll just quickly run through all the tools and parts that you're going to need to do the job, but as always there'll be a full list along with timestamps if you'd like to jump forward down in the description below. We are going to be demonstrating a few different methods, so you won't necessarily need everything shown here. Firstly, I've got some safety glasses, some gloves and some hearing protection, followed by an old toothbrush, brake and parts cleaner and paper towel, and a flat and round file for cleaning everything up. I've got some WD-40, but any penetrating fluid will work. You're going to need a paint marker or something similar, a flathead screwdriver, some locking pliers and a hammer. Back here we've got a 1/2 inch torque wrench and socket wrench with a 1/2 inch to 3/8 inch adapter, an extension and a 14mm socket. I adapt the 1/2 inch drives down to a 3/8 inch because it's a little bit narrower and it allows you to get to the nuts. Then we've got a 14mm ring spanner as well. Over here I've got a grease gun with a new tube of a high quality lithium wheel bearing grease. One tube will be more than enough. Then we've got a U-joint or ball joint press. It's not essential you use that, but we are going to demonstrate it. I've got 2 clamps here, or you can use a bench vise if you have access to one. Then I've got 12mm, 17mm and 21mm impact sockets, and a 1/2 inch brass bar helps if you have one. Then I've got 2 blocks of wood, a 32mm and 35mm hole saw, and then a drill. Lastly, for the parts we're going to be installing, you're going to need 2 universal joints per propeller shaft, so 4 in total. As for how you select your part numbers, I'll demonstrate that in the next section. All of the universal joints from Terrain Tamer come with grease nipples, so you can re-grease them, which I really like. So for example, if you go through a water crossing and you want to purge out the old grease or grime, you can do that. And in general, as a rule of thumb, you want to re-grease those every time you do an oil change. As always, we've chocked the wheels before we start. This is a propeller shaft that was removed from another 80 Series Landcruiser, and the main function of these is to transfer drive from the transfer case in the centre of the vehicle through to the front and rear differentials. At each end of each of your propeller shafts, you can find a universal joint, also known as a spider bearing, like this one. And the main symptoms of a bad universal joint are that you hear a clunking sound when you move from drive to reverse or vice versa. That can be caused by some play in the uni joint. Secondly, if you hear a squealing or a grinding noise from underneath the car, typically driving at lower speeds. And lastly, if you can hear or feel a vibration from underneath the car while you're driving as well. Unfortunately, all of those things can be caused by other problems, so we're going to jump underneath the car and get a closer look. So this is the transfer case here, in about the centre of the car, and at each end it has an output flange, one here and one here. And each of those output flanges is connected to one of your propeller shafts. So you've got your rear propeller shaft here going to the rear differential, and your front propeller shaft here going to the front differential. Looking close up at one of the uni joints now, and I'm just using the rear differential end as an example, we're going to check for play in the bearing. And the way that we're going to do that is you want to hold onto the shaft and try and move it up, down, left and right, and just see if you can feel any play there. I can't feel much at all, and that's good. You can also take a screwdriver and just use that to give yourself a little bit more leverage. And if you can feel play in the bearing, that's a good sign it needs to be changed. The other thing to look at is at the base of each of the 4 joints is a dust boot on the inside, and that's just there to stop dirt and debris from getting into the needle rollers. As that wears out and dirt gets into the bearing, it's going to cause the universal joint to fail, so we're going to be changing these out as a bit of preventative maintenance. The 80 Series came with one size universal joint for the front propeller shaft, but 2 different size options for the rear. And unfortunately, there's no way, for example, just looking at the year your car was made to determine what size that is. So we're going to need to get underneath and measure it. There's 2 different measurements you can check. The first one is to measure the diameter of the bearing cap. So that's this dimension here. Type A, which is the smaller option, and it's the same as the front universal joints, is 29mm across, and Type B, which is the larger, is 32mm. I can see that this bearing here is 32, so I'm going to need the Type B bearing. The other dimension that you can check is the distance from one end cap to the other on the opposite side. For the Type A smaller bearing, it's going to be 77mm, and for the larger, it'll be 92 for Type B. So we're going to need 2 Type B bearings for this rear propeller shaft. Before we remove the prop shafts, it's really important that we mark everything up to make sure we can put it back in exactly the same position. These shafts are balanced and phased because they're spinning at really high speed. If we don't get this right, it can cause some pretty serious damage. Then we're going to move to the other end and do the same thing. Once you've got everything marked up, we can start removing some bolts. We're going to show you the entire job for the rear propeller shaft. The process is exactly the same for the front, so we'll show the information for both on screen. So there are 4 of these studs at each end of the prop shaft, and you need a 14mm socket for these. I like to use a 3/8 inch socket on a 1/2 inch adapter to allow me to use the breaker bar, and the reason for that is the 3/8 inch is a little bit narrower and it allows me to get in there with a socket. Once you remove the 4 washers and nuts from the transfer case end, we're going to move on to the bolts, nuts and washers at the other end. So same for the differential end, these use a 14mm as well. With these ones, because they're a bolt as opposed to a captive stud at the other end, you may find that you need a 14mm spanner to hold the other end from turning. Put all those bolts, nuts and washers in a pile off to the side because we're going to need to use them again later. Now that we've removed all the fasteners, you can take a screwdriver and just pry it between the flange to get it to drop off. And then we'll do the same thing at this end as well. We've moved to the workbench to make things a bit easier to see. When we spoke before about the phasing, we're talking about the orientation of the yokes at each end of the prop shaft. So on the rear prop shaft, by design, the 2 yokes are in phase, meaning when this one here is vertical, the other one is vertical at the other end as well. On the front prop shaft, it's actually 90 degrees out of phase by design, meaning that when this yoke is horizontal, the other end is vertical. And it's really important we include those markings at the beginning, because if you don't put it in the correct phase, it can cause major damage to the differentials. One more thing to watch out for on lifted 80 series in particular is the front propeller shaft hitting the sway bar. What that looks like, you can see some scoring or even some slight grooving where it's been rubbing against the sway bar. And the reason that that happens is that when you lift the car, you actually move the sway bar closer to the prop shaft and it can cause that rubbing. By design, you'll actually be looking at the other end of the prop shaft because the wider section will be closest to the sway bar. But on this car, it's actually been reversed end for end to give a little bit more clearance with the narrower section here. But unfortunately, it was still hitting the sway bar. If that's the case for you, we're going to put a separate video out with a fix for that problem. We've clamped the prop shaft down to the workbench on a couple of blocks of wood. When you do that, just make sure you clamp it nice and close to the end where it's reinforced because we don't want to squash the shaft itself. First thing we need to do is to remove the 4 circlips or snap rings that hold the joint captive. And the way that we do that is we're going to take a flathead screwdriver and pop it in behind the edge of that clip and smack it out with a hammer. Once it's out most of the way, you can put your screwdriver in and lever it out the rest of the way. You can throw those ones away because we're going to be installing new ones. So repeat for all 4 circlips. And there we go. Now those 4 clips are out, we can start to remove the joint. We've just sprayed some WD-40 down into the top of the bearing cap. We're going to use a 21mm impact socket and our vise grips just to save our fingers. And we're going to hit that with a hammer to tap the bearing cap down. And you can see there that it started to go down in the hole. Alright, now once it's dropped all the way through like that, we're going to flip it over. So you can see that the bearing cap on the other side's been pushed through. So take your vise grips, we're going to grip onto the bearing cap and pull it out. And there we go, the bearing caps come off. You can put all the old bearing caps along with all the old circlips in the bin pile. Now to remove the other bearing cap, we need to tap it back through. So make sure you line up the bottom bearing cap with the hole, and then we're going to tap the top here to get it started in the bottom hole. Once you get below flush with the ears here, I'm going to take a 12mm socket in the vise grips and use that to hit it the rest of the way. Once you've hit it all the way down, we're going to flip it over again, and then we should be able to just pull that bearing cap out. And at this point, you'll be able to remove the flange from the prop shaft. So the other method is the C-frame press method. You could use the hammer and sockets for the flange as well, but we're just going to demonstrate this. So you line up the bearing cap with the hole at the bottom of the press, and if the bearing cap isn't going to fit through that hole, you need to use an adapter that comes with the kit. And then we're just going to tighten up this screw at the top, and that's going to push the bearing cap down into the hole. And same as before, we've sprayed some WD-40 in here before we started. And there we go. Once it's all the way down, we're going to back that screw off. So that's how to use the press. At this point, you would just remove the cap, push it back through, and remove the other cap using the vise grips in the same way that we did in the previous method. And at this point, you'll end up with the flange by itself. Now we're going to be removing the flanges at both ends of the prop shaft, and they're pretty hard to distinguish. So what I like to do is to turn it over and draw a little mark on this side and a corresponding mark on the shaft, and that just makes sure I don't mix up which flange goes at which end of the shaft. So I'll just show you another tip that can be quite useful if you're going to be using the hammer and socket method on the workbench. So I've got myself a 4x2 inch block of jarrah, and it's important that you use a hardwood for this. And I've drilled into the block of wood about 20mm deep, a hole that's just larger than the bearing cap. So what I like to do is, if I'm using a 32mm bearing cap like these ones, I've gone for a 35mm hole. And if you've got the 29mm bearing cap, you might go for a 32mm hole. And I've just done that using standard hole saws on the end of a battery drill. So with the block of wood on the workbench, have the hole face up, and we're going to put our yoke down onto the block of wood. And you want to line up the bottom bearing cap on the other side with that hole. And this just gives you a really solid way of supporting it while you're hitting it. And this bearing cap on the other side is going to be pushed down into the hole. The same as for the other end. We've already removed the 4 circlips using that same screwdriver and hammer method, and we've also pre-soaked the bearing caps with a bit of WD-40. Alright, so once the bearing cap's all the way out on this side, we're going to flip it over, and same as before, we just need to use our vise grips to remove that first bearing cap. There we go, that's come off, and that can go in the bin. So same as before, we want to line up that bottom bearing cap with the hole underneath. We're going to tap on the top just to get it started. Once you get to the point where this inner race is flush with the outside of the yoke ear, so flat across the top here, you want to make sure you line up the bottom cap with that hole again. And then at this point, you can use a small socket to continue to hit this down through the hole. But if you have it available to you, a brass drift like this one is going to give you much better control. So in this case, I've got a 1/2 inch drift. And I'm going to place that on the end of that inner race and just continue to hit that down. And you can see there that the cap's already starting to come through. So I'll just make sure that's sitting in the hole. Right, now once the cap's all the way out like that, we should be able to remove the flange, just like that. And then again, we can take our vise grips to remove that final bearing cap. And there we go, that's off. Once you have the flanges removed from each end of the prop shaft, it can be easier to use a bench vise like this one if you have access to it. So I'll just demonstrate that method for the last one. So we're going to clamp it with the bearing cap sitting vertically. And you want to try and clamp it on the vertical straight flat section as opposed to the section with the bolt holes. As always, we've removed the snap rings from both sides and we've soaked it with some penetrating fluid beforehand. So that's all the way through, so we'll flip it over. The downside of this method is you will get a bit of cosmetic damage and paint taken off the side of the flange. If your uni joints have the grease nipple, also called a zerk, on the body center, like this one here does, just take care with that because that can actually be the first thing to hit the flange here. So once we're all the way home, we'll flip it over one more time. We're now able to remove the uni joint. If you've got a stuck bearing cap like this one and you're finding that the vise grips just aren't quite enough to get it loose, what I'm going to do is hit it back down and through all the way, and then it'll pop out here. I'm able to do that because it's the second out of the two caps in this joint. If it's not, if it's the first one, what you want to do is hit it back down and in, so reset the joint to how it was originally, and then repeat the process. Because the act of hitting it back down and then up again is going to loosen it up a bit, and then you can try again with those vise grips. And there we go, it's just popped out the bottom. And you can see there the downside of using this method, a bit of marking on the side of the flange. We're going to clean that up in a minute. Alright, so next up we need to clean up the tail shaft. And what I've got for that is some brake and parts cleaned as well as some paper towel. I've also got an old toothbrush, which is quite helpful for scrubbing things, and then a screwdriver as well, just for getting into some hard to reach areas. Lastly, you want to have your paint marker handy because we want to make sure that any of these markings that get rubbed out, we put them straight back. Take care not to use anything hard on the bore inside here because we want to make sure we don't scratch that surface. This end's called the slip yoke, and it's named that because it's able to slide in and out of the main propeller shaft body to effectively increase or decrease the overall length of the shaft as your car's suspension moves up and down. You can remove the slip yoke from the rest of the propeller shaft. Just make sure that you've maintained the marks on both sides because it is a splined connection and you need to make sure you get it back on the same spline. And there are those splines that I was talking about. Now it's really important we avoid getting any dirt or contaminants in there, so I'm just going to put this off to the side for a sec. Now there is a grease seal in the main propeller shaft body that rides on this surface here, so I'm going to give this a really good clean. Make sure you don't use anything hardened because we don't want to scratch this nice cylinder. Alright, there we go, nice and shiny. Now you just want to make sure you put your paint markers back on as they were. And we can reinsert that slip yoke back into the main propeller shaft. Now, the most important thing when we do this is to maintain the phasing of the shaft. And that way you can tell if you lose your markings or you're not 100% sure, you think you might be one spline out or something like that, you make sure you move it into the position where those ears are in phase. If you have the front propeller shaft, it's 90 degrees. So when these are vertical, the other end would be horizontal. And as you can see there, while the yoke at that end sitting flat on the block of wood vertically, the other end's sitting flat as well, so I know I've got it in the correct position. The last thing to do before we install the new uni joints is to inspect the bores. Now you want to make sure they're all nice and clean and nice and smooth, so no deep gouges in there. And additionally, we want to check for any sharp burrs on the outside that might have been caused when we tapped the old bearing caps out. If you do have any sharp edges on here, that might damage the new bearing caps when we tap them in. So in that case, we're going to take a round file, like this one, and we're going to make sure that we're not scratching the bore itself, but rather just lightly removing any burrs from this outside edge. So you're not removing much material, just trying to deburr it. And that one looks okay. And you want to repeat that for any of the yokes or the flange yokes that have that sharp edge. And then we'll give those bores one final clean with some nice clean paper towel and brake and parts cleaner. When you open up the new uni joint, you'll find that they come with a separate bag with your 4 new circlips, as well as a new grease zerk in there. And then you've also got the new joint pre-assembled with the 4 bearing caps in place. These particular uni joints from Terrain Tamer are re-greasable, and they come for the rear with the grease nipple on the body center, and for the front you have the option of either on the body center or on the end cap. I like to go for the body center personally. There is a correct orientation when you're installing these, and we'll show you that now. What we're looking for, number one, is to make all three fittings, so that's the one on each of your uni joints at the two ends, as well as the one on the slip yoke, be in a line so that you can grease them all at the same time when you're underneath the car. And the other thing is to make sure that the grease fitting is pointing back towards the prop shaft. In other words, it's facing away from the flange that will be here, because then we're going to be able to access it with our grease gun underneath the car. So I'm going to install my uni joint in the orientation shown here, because then I've got the zerk pointing towards the middle of the prop shaft away from the flange, and also in a direction where I'm going to be able to access it on the same side as this existing zerk in the slip yoke. So what we're going to do now is remove the bearing caps from that uni joint. Now when you do this, there are needle rollers inside there and they can fall in on themselves, so you just want to take care. If they do fall in, you can see the rollers in there, you can take a flathead screwdriver and just gently restack them if you need to. So we're going to put that cap off to the side and just make sure we don't get any dirt or grime in there. Then we're going to remove the other cap from the opposite side as well, and that's going to allow us to pop the joint in between the two bores, like that. And then I'm going to drop my bearing caps back in. And when you do this, just make sure those rollers don't fall in on themselves. If your uni joints didn't come pre-greased, you do want to put a bit of grease in here by hand, but these ones from Terrain Tamer do come greased. There we go, so I've got my slip yoke sitting on a block of wood, and then I've got my bearing caps in loosely. I'm going to take the hammer and I'm just going to slowly get it started. You want to make sure it's going in nice and straight. And once you're happy that's started, we're just going to hit it the rest of the way. And you'll see that it'll start to push the bearing in the bottom and at the top. Alright, so once that's sitting pretty flush with the top of the ear here, I'm going to flip it over and repeat the process for this bearing cap. And there you go, you can see both sides are about flush with the slip yoke ears. It's a bit hard to see, but what we're aiming for is to have the circlip channel here exposed. So I'm going to need to tap this in a little bit further until there's space for that circlip. Same thing on the other side, I need to expose the channel down the bottom here. You might find you get some grease coming out of the zerk hole. That's because we've compressed it inside, and we're just going to clean that up. What we want to do now that the bearing caps are both in is just to feel how the joint moves. It should be nice and smooth. If it's not smooth though, take your hammer and just give each of the ears a bit of a tap. And that'll free it up. So I can feel that's moving nice and smoothly. I'm happy with that. Now it's time to take the first of the new circlips that came with the kit, and we're going to pop that into the channel here. And then we're just going to tap it in with a hammer. And there we go, you can see it's just started to go in. It's going to be a bit hard to see on camera, but once the circlip looks like it's popped in, you just want to look down the bottom and just make sure it's contacting the bottom of that channel and it's all the way in, which it is. Then we're going to flip it over and do the same thing on the opposite side. And there we go, that's just popped into place. So once that one's done with the circlips fully installed and it's moving nice and smoothly, we can move on to the flange yoke. Now for this one, we again want to make sure we've got the one with the correct marking. And we also want to make sure we line it up with the match marks that we made earlier. In this case, I've got my white line here and my white line here, which I'm going to line up. Same as we did before, I'm going to remove the bearing cap from the top and the bearing cap from the bottom. And I'm going to sit the bottom bearing cap flat on the block of wood. And then from here it's going to be the same process that we just completed. We're going to tap those bearing caps in with the hammer. That's looking pretty good, so I'm going to flip it over. I know I've gone far enough because I've exposed this channel here where I'm going to be able to tap the new circlip into. There we go, that's popped in. Same thing on the other side. So once you're happy that both circlips are in on that one as well, we can just feel how freely it's moving. And again, that's pretty smooth. I like to still just give it a couple of taps just to make sure it's moving smoothly. And that's a really nice uni joint. So the last thing that we need to install is the new grease zerk, and we're going to be popping that in here. So you just want to start it by hand first. Once you've got it started, it's a 7mm socket, and we're just going to snug it down. You don't want to over tighten this because you'll strip it. Okay, so now we're going to flip it over and do the same thing to the other end of the tail shaft. You obviously can just use the hammer method again, but I'm just going to quickly show you how to do it with the C-frame press as well. So this time we're going to need a little adapter that goes in the end to fill in the hole, because we don't want the bearing cap to be able to fit through the bottom now. So it is a bit fiddly to get everything into place, but once you've got it set up, we're just going to tighten down on the top screw and it's going to push the caps into place. And there we go, that's all the way home, so I'll back it off. So you get the idea, it's the same process for both ends of the prop shaft. Once you've finished installing those last 4 circlips and the grease zerk, the last thing we need to do before we put the prop shaft back on the car is just to lubricate the unis. Now we're going to be using this Newlon Extreme Performance grease. It's a lithium based wheel bearing grease, which is what you want. And I've got a tube of that in the grease gun. You just want to press the end of the grease gun onto the grease nipple. And we're going to pump until grease starts to come out of the boots at the base of each of the uni joints. So I can see it's starting to push the other grease out. And that's looking good. I'm starting to see red grease coming out of all the boots. So I'm going to remove the grease gun and we'll just clean that up. I find it helps to take a nice clean screwdriver just to pick up some of the grease. You want to try and avoid leaving too much loose grease in here because it's going to catch lots of dirt while you're driving. Once you've finished cleaning that up, we're going to go down to the other end and do the same thing. And while you're here, it's a great opportunity to lubricate the tail shaft itself. So you've got this slip yoke joint here and it is greased. We're going to pump maybe 3 or 4 pumps into this little zerk here. So then we'll just quickly clean up any loose grease in here and we're ready to put the tail shaft back on the car. And I've just quickly cleaned up all the bolts, nuts and washers that we removed before with some brake and parts clean and a toothbrush. So we're going to start with the differential end and we're going to make sure we line up the match mark on the flange with the match mark on this flange here. We can start by loosely installing our bolts by hand and you'll have a washer and a nut on the back. Alright, so once you've got all 4 on loosely by hand, we're going to take the 14mm spanner on the back side and we're going to go around and snug each of them down in a crisscross pattern. You might find you have to maneuver the tail shaft a little bit to get to all of them. Once they're all snug, we're going to switch that 14mm socket over to the torque wrench and we're going to torque these bolts up. Now the torque spec is the same for both ends of the propeller shaft, but it's different for the front and rear shaft. So for the front, you're going to be using 54 foot-pounds, which is 74 Newton meters. And for the rear, you're going to be using 65 foot-pounds, which is 88 Newton meters. Once you've finished torquing up the 4 bolts at this end, we'll move on to the other end. With the slip yoke end, you'll probably find you need to compress it a bit to get the shaft length to be short enough to fit the flange over these studs. If that's the case and you find that you can pull it out but not push it in very easily, what's more than likely happened is there's too much grease in here and it's hydro-locked. So what we would do in that case is use a 7mm socket to remove this zerk fitting, compress it as much as you need to. You'll find that grease will ooze out, clean that up, put the zerk back in and snug it down, and then we can keep going with the job. So we're going to offer this up over the studs, and again always make sure your match marks are lining up. Now I can offer up my nuts and washers. The transfer case output flanges for both the front and rear don't have space for a full-size bolt behind the flange, so what they have instead are these serrated studs which have been pressed into the flange, and as a result of that it's critically important that we don't over tighten the nuts that we put on here. If you do that, you can actually strip out the serrations and this stud will start to spin, meaning that you won't be able to tighten or loosen it anymore. If that does happen, there are pretty limited options. Unfortunately, these aren't a serviceable part from Toyota, meaning you can't replace just a single stud, you actually need to replace the entire output flange, which is a bit of a pain. What you can do is try and get a bit of a tack weld on the stud, but that's quite tricky. And then we'll finish them off with the torque wrench, same specs as for the other end of that shaft. So 54 foot-pounds or 74 Newton meters for the front prop shaft, or 65 foot-pounds, which is 88 Newton meters for the rear. And that's it guys, just repeat the same process for the front and rear prop shafts, with the only real differences being potentially the size of the uni joints as well as the torque specs that we're going to use to do them up. If for whatever reason you need to replace any of the bolts, nuts and washers that fasten these on, I'll include the part numbers for all of those in the description below. One other thing I haven't covered in today's video but is covered in the factory service manual is runout, where excessive runout can also lead to vibration. Runout is basically a condition where there's a difference between the axis of rotation and the main axis of the shaft, and the way that you measure that is by setting a dial gauge on the shaft, rotating it, and then measuring the maximum expansion or contraction of that dial gauge. The maximum allowable runout for these shafts is 0.8 millimeters or 31 thousandths of an inch. That being said though, if you've replaced the uni joints or there isn't an issue with them and you're still experiencing vibration, so you think it might be the result of, for example, an imbalanced shaft or runout, then it's probably best at that point to consult a professional driveline mechanic. And that's it for today guys, thanks for watching. We really love hearing your feedback, so if you've got any questions or tips and tricks, or maybe something else you'd like to see in future, please let us know in the comments down below. Otherwise, we'll see you in the next video.